I start to talk about the recurrent neural network, and the reason why this network is important is that it can handle the time series data, and most of the financial data actually is a time series data. So we are going to talk about the neural network from today, and I think probably I'm gonna spend the the rest of the semester for the recurrent neural network. So today it is going to be very simple. So we are going to use the Music21 collab link, which is here. So I share this collab with you. So can you use this collab also?
Yes, we can.
Oh, okay, yeah, that's good. So it's a library written in some other language, but yeah, we can use it in Python. So the name is Music21. So we can import everything from the Music21. And then, the music. So I'm going to show you the first cell. The note. So the umpyo is a note, and we know some from some music theory that D sharp 3 is this one, and the duration type is half. And at first, this one does not the score does not comes up because there is some problem. So in the next cell, I showed you how to make some setups. So it's actually a comment. So there was a problem to the dot show method. And this is not the problem of the Music21. This is the problem with the collab, because the collab is not in your computer, it's in the other side of the world. So there is a way to communicate with the Music21 and the collab, and some smart guy make a solution, and it takes some time to set all these things up. And actually, you don't have to worry about this part at all. So it's just given to you. And since I did it already, I can finish it much faster. And there is some more setups, but we take these two cells as given. So once we accept that those two cells are given, then we can start it again. So we import everything, and then the n is a variable which has the just one node. So n that shows you this score, and play n means you can actually listen the sound of this note. So I can hear the sound, and I think you can hear it too. So this is just one sound, but actually the develop of the Music21, he is, I think he is a professor at MIT who studies about the music. So he has a lot of things, and we can take a song from his not his collections, but actually we know the older songs written composed by Bach. So this is just one example. So corpus means a collection of all work, and then we just take just one piece of work and parse and save it to S. And S dot shows you the whole score of that music, and play S actually lets you listen to the song played by computer. So let me show you. So this is the score of under this title. And then at the end, you can listen to the sound of this score. So I think, yeah, this is Bach. So just think about the music. You can think about the music as just the collection of notes. And these collection of notes can be represented by numbers, and these numbers have a sequence. So if it does not have a sequence, it's a little bit messy sound, but since it has a sequence, we can appreciate the beauty of the music. So to see what's inside this music, we are going to print it. So S is a variable name that contains the whole score, and we can print out what's inside. And it says it's a Music21 text box, and this is the title and some copyright information and soprano, alto, tenor, bass. And we can see that this is a kind of a list. So the first element is this one, actually the indexed by 0, and this is 1, 2, 3, and so on. So if I wanted to see what's inside the index 3, which is part soprano, I can do the similar thing. So for I is in S3, and then print I. Then I can see what's inside. And it's in the inside, it's a measure 0, measure 1, measure 2. And in Korean, the measure means the body. And we can see the offset, and I guess this is the time. So we start from 0, and then the first measure starts at 1 second from there, and from 5, 9, and so on. So probably it's another list. So we can see what's inside the list of S3. And there is an easy way to see all of this. It's called dot recurse. It means it is a recursively look inside. So S3 dot recurse is this one. And we can, yeah, read this part. Treble clef is a 높은 음자리표, and there are 2 sharps. So time signature, and then the note B and B, B, A, C sharp, and the second measure starts with some note. So since we are going to deal with the time sequence of notes, we can only see the notes only. So in S3, which is a soprano part, so you can change it to alto, tenor, bass by just changing the numbers here. And then recurse, and then we are going to pick the notes only. So instead of appending to here, I just wanted to print out the pitch. So we saw that, yeah, there are 3 notes at the same pitch. here in the soprano part, the 1, 2, 3, and then one down and goes up and at the same pitch, and all this pitch is written here. So we can make a list of all the notes. So instead of a printout, first I define a empty list, and inside that empty list, I'm going to append one note by note by note. So the empty list is called music, and music that append I is something that goes, it's an index, and pitch with the name with octave is just this one. So we can append all the notes to the music and see the music, and everything is inside a list, and each element is a string. So B4, 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 A4, C#5, and so on. So this is the way we extract information from scores. So for your assignments today, you need to extract all of these notes from some of the library. So in my example, I use this number, BWV 120.6, but there are lots of other musics, so you can choose your own music and then extract the notes. So in order to extract the note, we define a function. So I define a function. So this function is extract note and then takes input as a score. And then the temp is an empty list. And then we do the same thing. And then append a new node to a temp. And then finally, after finishing all these extractions, the temp will be returned. So here I take the number 4. 4 is the alto part. And then we can see all the extracted note. Okay. So this is just the beginning of our neural network. And then once you are able to extract all the notes, and you are going to put it into the neural network and make a new music. And then that final music should be into a music again. So let's make another function to make these letters into a music. So this function is data to music, and it takes X, and X is a list of letters. And stream.stream is given by the Music21. And then from the list of letters, we can make a note and then append it to a stream. And then we can show the stream, and we can, so we can show the stream and return this stream. So this is the function from a list to a music. So in this example, the music note is just the list of letters, and then applying the data to music, it will return a stream, and then we can play that stream. So let me run. And it takes a little bit of time because it needs to generate the music. And all the notes are different. So now you are able to extract a note and then do something. Yeah, I'm going to talk about how to do something on that extracted note. But after you finish some manipulation, you will get another list of notes, and then you can make your notes into the music using this data to music and play the variable. So, for example, now I can make my own music. And the only the song that I remember the pitch is the sol 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 la la sol sol mi, and we can interpret sol as G4. So you see the do re mi fa sol la si do is in English is a C D E F G A B C, and the 4 is the octave. So if you know how to play the piano, yeah, it's just a standard notation. So my song is just a list of the valid notes. And then I can put this data to music and then make it play. Okay, so yeah, listen carefully at this part. And once you make your own music, you have to save it to the Colab. And this is the function. Your music dot write, and you have to specify the format. So the MIDI is the special format for the music, and then you can make your own name. So I said, yeah, this is my song, but you can make your anything. Yeah, it's your music. Then on the left hand side there is a folder, and once you inside the folder there is a file. You just named it mmm.mid, and you can download it. And once you have downloaded this MIDI file, then there will be a player, the music player, who can play this MIDI file. So this is your this week's assignments, but not yet. But what you have to submit is the MIDI file of your own, not this one. So I'm going to listen, everything, and if you just send me this one, then you cannot get a credit. Okay, so is there any questions so far? This is just how to extract the music and then make it play and then save it to your computer. So if you have any questions so far, please let me know. Okay, if you don't, send me a heart. Okay, we have some questions. Oh, I will let you know, how long, So at the end, you can create your own music. For today, I'm going to show you a much easier way just generate a music. So you have to submit your own generated music, not the already known ones. Yes, and I will let you know how to do it very easily. Yes, but this is just the beginning. So we start from a well-known music and then extract the information and do some process and then save it to a new music and then submit the new music. I can listen your MIDI file, and then if it plays well, and if it is too good, that means probably you are gonna just download another things and submit it. So I don't want this music is to be too good. Yeah, just here make your own music and then submit it. No, not yet. The codify is a much more difficult thing. So I just want to show you the meaning of the codify. Actually, it takes quite long, especially at the beginning. The sum setup and the code that starts with the capture, and it will take about 2 or 3 minutes. But if you still cannot do that, then you have to start it again. So this is the notebook shared by me. So once you have opened your notebook, you need to save it to your own version. So there is a save it to your own version, and then you can modify yours. No, not from the scratch. We are start from, so you are going to start from your choice of Baha, and then make a new song from that your choice. So please do not start with the same song that I used. There are a bunch of other songs. So for example, you can go to the Music21, Music21, and the first link is not that good because they did not update to a newer version of the website. So probably the second link gives you a better documentation. Or you can search for Music21 corpse. And if you read carefully, here is a list of work found in the Music21 corpse. So for the Bach, this is all possible choice of yours. So I just select the, I don't know, 120 something, but this is all different music from the Bach. And you can also choose another composer, not just Bach. So try some other things. Yeah, and essentially we are going to make a music through the TensorFlow, but for now we just pretend to be a computer, but eventually we will let the TensorFlow will do the job. Your submission should be in the format of the MIDI file, and the MIDI file should end with .mid. So it's the DT is your name of your choice, and then .write, the MIDI, you have to specify the MIDI in order to save it to a MIDI file. And then you need to write down your choice of file name. And that file name should end with .mit. And this is the standard format of the MIDI file. And then once you have your MIDI file, please listen to your music. And then if you're satisfied, submit it to the Learn Us, the assignment RNN here. Yeah, so this is going to be a little bit controversial issues. So we just take the song from the Bach, and then we are going to build a neural network model that can use the Bach's music to generate a never heard the Bach's music, never heard the actual Bach, but it is going to be a completely new. Then who is the owner of the music? So, but our generated music will not be so good as Bach, so we don't worry about too much. Not yet. Yeah, I'm going to go a little bit more, and you have to use some more things to make your own music. Yes, sometimes for the Mac users, there is always I don't remember the name of the program, but for the Mac users, the MIDI is always open. But for the Windows users, you have to download some MIDI players, and you can very easily find it on the internet. Oh yeah. For the Mac, it was GarageBand. And for the Windows users, yeah, you can easily find the software that can play the MIDI music. No, you don't have to download the Music21. It is already downloaded into the core app. And if you really want, you can download the Music21 in your own computer, but I don't think that's necessary. Yeah, so our actual purpose is not to generate the great music. I just wanted to let you know how recurrent neural network works. And then we are going to use these kind of things maybe for stock price predictions. So you may think this is some music, but for me, the stock price or the Bitcoin price, the music, they are all a sequence of numbers. Okay. One more question. You that is for me, that is impossible. If you are not unable to download the file because of your computer's capacity, it's if you use the modern computer, you should be able to download it by just pressing the download button here. You see, it's my song.midi, and there is a download button, and it should be saved on your computer. Okay, let's go a little bit more. So codify, I intentionally add this part because the music we are going to make is really simple, but if we really wanted to make a beautiful music, we need some codified the music. So this score is just generated by the Music21. This is not the actual one. And do you remember there's a soprano part, alto, tenor, bass, and then all these 4 notes goes into one place. And that's what the Music21 did. So if you can play the piano, try to play this one, but probably you cannot play this song by just looking at this score, because this is not for the human. But we can still listen. Actually, that's the same music. So now we are going to connect this Music21 into the TensorFlow. So import NumPy, import TensorFlow, and import Music21. So we can import, and then choose your choice of music, and then s-show shows you this one. But since we already defined a function to extract just one part, the soprano, alto, tenor, or bass, whichever you want, you can extract one of them. And remember that the index 0 is just a title, and that might be different from the different songs. So you have to verify that which track and which list is actually on music, not just the title. So maybe I can select 5. And this extract note produce a list with the notes in it. Oh, okay. But there's no problem, because you can, once you make your song, you can always listen in the collab. And if you are satisfied with your music, then just use your music.write MIDI, your file name, and then just submit your MIDI file, and that should be okay. So you don't have to download the MIDI software for your own, because the MIDI file is the smallest size of the music file that can save lots of information. So that's why I choose the MIDI file format. But you can listen your music by just play here. The play is a new function. The play your music, then you can listen to your music by pressing the button. No, not your own work. I want you to do some collab, and actually TensorFlow will do that for you. So if you start watching this and, oh, okay, I just write any sol sol la la sol sol mi thing, then I cannot accept it. You have to go all the way down to the TensorFlow And then TensorFlow will do that for you. Okay. So I still use the same example. And then we can see, we can use the function extract nodes, and that function is defined by me in the previous cell. And then the set ds. So set is a Python type. So do you remember the Python types? In the basic form, there are 4 different types: int, float, string, and boolean. And in the composed type, the list, dictionary, tuple, and the less not widely used one is actually a set. And set is really a set. So before I do this one, let me show you what's inside the DS first. So it's print DS. And it takes some time to extract the, I don't know which one. It's 3, 4, 5, and it's a 10 apart. So there are lots of nodes. But if you take this list as a set, to remember the set elements can be unique. So here, F#4, F#4, you don't need the several of them. So you just need one. So that's what set means. So set DS shows you the unique nodes of the whole song. And there are several of them. But it's A, B, C, I don't know. And then so this is the set format, and set is very useful to find the unique elements of a list. And then make that unique elements into a list and save it to vocab. This is a name for the vocabulary. And then what we are going to do is to change all these musical notes into numbers. So maybe I can say A3 is 1, B3 is 2, and C#4 is 3, and then replace the whole music as just a number. And for that purpose, we have a new layer, and this layer has a very long name, but it's TF, keras, layers, and it's experimental layers. So experimental, pre-processing, and string lookup. So string lookup basically means to find a string and then change it to a corresponding number. So how can you use this string lookup? In order to use the string lookup, you need a vocabulary, and that vocabulary is a unique element of your whole list. So that's why we make the vocab here. So now the vocabulary is vocab, and then call this one as F1. Then with this vocabulary, there is going to be a transformation function inside this layer. But actually, that transformation has not been made yet. So actually, in order to apply the transformation, we have to call the F1 with our data set. So F1 data set, we get a list of numbers, and these numbers corresponds to each node. So for example, let me see the print here. So it's D4, D sharp 4, E sharp 4. So probably the D4 is number 2 because it's here. And then, okay, what is the easy one? Okay, here is 11 and 11, and it was on the 4th and 5th. So 1, 2, 3, 4, and 5th. So 4th and 5th are the same notes. So it has the same number. So this is the way we can easily transform the notes to numbers. And one thing you need to notice that is there is no 0 and there is no 1 in that transformed numbers. The reason is that the 0 and 1 is reserved for the TensorFlow. The 0 means empty, and 1 means unknown. So we know that, yeah, this is, there are not so many different notes, but what if we add a new note never seen before? Then that note will be mapped into unknown, which is number 1. Anyway, yeah, in our case, we don't have such a things. So this is the music represented by IDs. And for simplicity, we just ignore the duration of each note. Some are the quarter, and some are half, and some are eighth, but we just ignore all of them. So suppose you have a bunch of numbers, and then I want to put it back to music. So there must be some way to do the reverse things. And actually, the same layer, TF-Keras layers, experimental preprocessing, and string lookup has the ability with just one additional parameter. So invert is true. And here, the vocabulary, we can use the previously defined vocabulary, but since I said the number 0 and number 1 is a specially assigned vocabulary, in order to incorporate these two, we can use F1 dot get vocabulary. And actually that F1 or F2 is a name that I chose because in the original TensorFlow documentation, it was ID from characters or character from IDs, but that was too long. So I just forget about that. And I just call F1 is from music note to number, and F2 is number to music note. So F1 get vocabulary means use the F1 functions vocabulary, and then invert is true. So that is the F2. So let's think about this statement. So DS is our musical notes list, and then apply the F1 means we can transform it into numbers, and then save it to TMP variable, and then that P variable will be applied to inverse function. And that is going to be this one. So it's D4, D sharp 4, and we can compare to the original version, and you will see that these two are actually equivalent. But there are some other things, like the B, and all of these in tensor format. So we have to deal with that. So actually, the concept of the recurrent neural network is not so difficult once you understand. Maybe spend half an hour, you can understand it. But the most difficult part of the recurrent neural network is make the data that will be suited to your RNN model. So this is a very hard step. So ds is just the same thing, and we can compare these two are equal. And how can I see the arrays part only is f2 tmp dot numpy. Then originally it was in a this whole thing is a return. So it's tf tensor, shape is 72, means there are 72 nodes, and the data type is string, and numpy representation is this. And in order to see the only numpy representation, I can say f2 tmp dot numpy. Then I can get the numpy representations. But I want to put it back to the normal list without b. Here the b, b, b. So how can I do that? Is that we just take the numpy part and then call it in temp2. And then temp2 is actually a list. But the numpy has a special ability, a special function to transform the byte code, which is here, the byte code, into the just a string. So that is called decode, and the decoding scheme is UTF-8. So you probably heard about the UTF-8, even though we do not know exactly what it means. So sometimes, since we use the Korean letters, sometimes if you see something cannot be shown exactly on the screen, that's usually the problem of the encoding and decoding. So here, the decode UTF-8 transform the B version to our usual string. So this is the way we get a list. And since once we have a list, then we can always put it back to music with the function data to music. And then we can play this data to music function. Then you can listen. Okay, questions? Oh, okay, I can say more than 1 minute. This one, so how can you see? Okay, more than 30 seconds. So this one is 35 seconds. No, more than 1 minute. Yeah, because in that way, you have to choose some more longer music. So more than 1 minute. So that's the requirements. Actually, I don't know what that UTF means. It is just okay. I know what it is. In older times, when computer was first made, the Americans made the computer, and they think that all the letters they can use is just the alphabet. So they make their alphabet into the computer numbers, and that is called the ASCII code. And ASCII is it's not an English word. It's a abbreviation for some computer terminology. So it is called the ASCII code. And in that ASCII code, there are lots of languages that cannot be represented by ASCII because there was no corresponding letters. And especially it was hard for the Asian languages. So the French, German, Yeah, there are some minor changes, but they all looks like the alphabet. But the Chinese letter, Korean letter, and Japanese letter, these three letters were really problematic. So there were lots of attempts to transform the world language into the computer code. And finally, we find the solution. That is the UTF-8. UTF-8. And this is a pretty clever solution because you may think that, okay, I just since A is number 20, B is number 21, that I can make every character in the whole world corresponds to just one numbers. But think about the Chinese letters. There are so many Chinese letters, but still the Chinese letters can be represented by some computer code. So every Chinese letters, I mean, it's, see, this is Chinese one character, and this one is another one, this one is another one. And they can be represented, even though they are very complicated, everything can be represented by the computer language right now. So this scheme use a very clever idea, which does not require that much memory and which does not require that much computational power, but still able to translate the characters into the computer language. So that's the meaning of the UTF. Okay. Yes, for right now, we are not able to use the chord because the chord has, at least, so in the box example, there are at least 3 or 4 notes at the same time. And at this time, we are not able to represent that chord into a number. What we can do right now is just to represent one note into a single number. So today's assignment is not for the chord. And we are going to use the TensorFlow today. So I'm going to show you. Yes, you have to upload the MIDI file, not the Colab. One simple way is to make your list bigger. You see, suppose this my list is my final version. But we know that how can we add list? So go to the datacamp.com, and there is a way to add 2 lists or even multiply lists. Then it's getting longer. And then we can also make it a music. Oh, it's not just a list. It's on my list times 3. So it's 1 minute and 44 seconds. Of course, it repeats. So make it longer is not that bad. Oh, sure. Yeah, I will. Yeah. Yeah, we don't use the Kaggle competition this week. You just make your MIDI file and then submit to the Learn Us directory. Yeah. So making notes by the collab and then produce the file in MIDI. Yeah, that's right. Oh, yeah, that would be a good idea. So your file should have your file name should contains your student ID. Yeah, that's a good idea. So for summary, I think we did a lot of things, but this is what we did so far. And there are lots of comments. And conceptually, it's really simple. You took a song from the corpus and then just extract notes from that song. And then find the unique vocabulary for that song. And we define F1 and F2 with vocabulary is vocab, and the vocabulary is F1 get vocabulary and invert is true. So one is to transform the musical note into the numbers, that is F1, and F2 will do the reverse thing. So from the numbers to the musical note. So that's, yeah, what I did here. So it's F1DS, it's data set, and what's, oh, it's data set. Oh, okay. And then from this part, so there will be a place that your TensorFlow code will do some jobs for you. But right now, we just pretend that, yeah, the random choice is a TensorFlow. Of course, this is not the random choice, but you can just select the numbers randomly. And I said the size is 35. So that means from all your notes, you can just select 35 nodes and then save it to output. And then this output contains the numbers. So we are going to change to a musical note and take the NumPy part and then decode into the string and then play it. So that's all we did so far. And listen to the music. So I think, yeah, it's not that bad because Bach used the very right notes, yeah, very the good good not good looking. I don't know how to say it. 굉장히 잘 어울리는 he used the very harmonic notes. So even if we choose randomly, it still is good. So now from this part is just a copy of the TensorFlow code, and it's pretty long. And I will explain this, yeah, TensorFlow code. This is the part that I'm going to explain now. So I did not change. I did not explain how to change the melody yet, because what I talked so far is to how to extract the notes and then convert it to numbers. And then once you have numbers, then you can transform it back to the musical note and then play it. I want to make this week's assignment really easy. So you don't have to use the TensorFlow code, just use the random numbers. I saw you before. There was a Okay, so vectorize the text, and then there are two main outputs. Yeah, here, so you can use random choice. Then you can make your music and save it to the MIDI file and then submit to the Learn Us website. That's your this week's assignments. So it must be much easier. Now I'm going to go to the simple RNN calculation collab, because in the first collab the things left is a little bit complicated. So I'm going to go to the simple RNN first and explain what RNN can do. And then next week, we are going to make a real music. So let's go to I want to change your the original music also. So do not try to the same the Bach music. So at least you need to change to another Bach and change the random numbers. Yeah, and I want you to do the whole process by yourself. So this is just a encoding and decoding of your music, and the random choice part, I'm going to explain the random choice part in terms of the TensorFlow. So from this and then to the next week. So go to the simple RNN calculation codec. So here we assume that we don't care about the encoding and decoding of anything. We are just given a series of numbers, a sequence of numbers. So first we import the NumPy and TensorFlow, and we are going to make some arbitrary numbers. And we pretend that that's a music sequence. So it's just a 0, 0, 0.0 and 1.0, 2.0 up to 9.0. So there are just 20 numbers. And then what I wanted to do with this 20 number is that I want to make this one to be suitable for the RNN problems. So for the RNN problems, so what we are going to do with the sequence data. So maybe we have 1, 2, 3, 4, and 5. And usually what we wanted to do is to use some previous knowledge and predict the next number. That is usually what we are going to do. So in order to do that kind of things, we have to make our data set is suitable for that training. So one way to do this is that, okay, I'm going to make 1, 2, 3 is going to be my X, and then 4 is going to be my Y. And then 2, 3, 4 is going to be my X, and 5 is going to be my Y. And of course, if we have some more data set, we always have some input sequence. And then here we have just one output, but sometimes we wanted to have a sequence of numbers. So let's say it's, so 1, 2, 3, and 4, 5, 6. And 2, 3, 4, 5, 6, and 7. And 3, 4, 5, we need 6, 7, 8, and so forth. So we should be able to make this data set into this data set. So that is the first step. And so here is another pre-processing layer. It's TF-Keras pre-processing time series data from array. And there are some arguments. So data is data. So the data means these 20 numbers. And target is usually none. And when we need this target is actually if you wanted to predict something new, not just inside our data sequence. So what I mean by that is, let's say we have temperature at every hour. So it's 23 and 24, 30, and so on. And sometimes with these temperatures, we can predict the 1 hour later temperature. In that case, the target is none. But for instance, I have a series of temperature, but I want to predict the wind direction in 1 hour. So it's to west or the south or northeast. And in that case, the input data and the target data is totally different. In that case, we need to specify the targets. But in our example, we don't have a target because our input data can be also used as our output data. So data is enough. And then sequence length is 10. That means I'm going to take the 10 numbers, every 10 numbers, not just every 10 numbers. I just want to move it 1 to the right, 1 to the right, but the total length is 10. And batch size is 3. So let's see what's inside. So what's inside the DS? So the DS is now a TensorFlow dataset type, and it's not easy to see what's inside by just typing the DS. So one way to see what's inside in DS is for I in DS and print I. Then it will show you the already made the data set by applying these layers. And there are so many. So if I wanted to see just the first one, I can say DS take 1. So here, DS take 1 means just the first example. And DS.take 2 means take 2 examples from the first. So take 1 means just take the first example and print I, and it will gives me some data set like this. So it's from 0 to 9, which is 10, and from 1 to 10, which is another 10, and 2 to 11, which is another 10. So that's the why I have 3 separate 10 numbers is that I said the batch size is 3. And then each example has a sequence length of 10. So I can change it to fit in just a small screen. So I said the sequence length is 5 and batch size is 2. Then there is 5 numbers, and there is another set of 5 numbers. So that's the way you handle the data set. Okay, now let's say I have the number from 0 to 4, but I want to make these 5 numbers into 2 separate pieces. The first one is going to be an X and the final one is going to be on a y. Oh, this is right, yeah. 4, this is just -1. Yeah, this is what I was trying to say. Oh, the students who give me a hint is really smart, because the x is actually a two-dimensional array. So I have to consider 2 dimensions. So first, I'm going to take all of them, and then in the second dimension, I start from 0 and up to -1, but -1 is the last one, and that last one is not included. So in this way, I can take 0, 1, 2, 3, so which is here. And then for the second part, I'm going to take all the first dimension and then just take the last one. That means just 4. So this is 4. So this is, yeah, this is always the hardest part of the modeling. So the data manipulation is really, it's a pain. Anyway, yeah, for the help of her, I can manage to this. And I'm going to skip this part. Okay, so let's consider very simple model. It's just TF-Keras sequential, and then there is just one layer. And there are 3 different neural the RNN models. The most simple one is the simple RNN. And I'm going to put just 1. And I don't know what it means right now, but take this one. Oh, I shouldn't delete the first part. So, okay, I'm going to add. Okay, so from the map DS, and there is another way to see what's inside. So let's just do it. And then we have A0 is the X only. And then define a model. And then just put the A0 inside the model to what we can get. And you see, there is an error. That is always a problem, because the last error is a hint. The sequential 2 is compatible with the layer. Expected dimension is 3, but the given dimension is 2. So that means the A0 should be 3-dimensional. And that is very important in the RNN network. So do you remember that when we first defined the dense layer, the first layer should have the input shape information. But for the RNN layer, it does not need the input shape information, because the input shape is already given by itself. So it has it should be always in 3-dimensional. So first dimension is number of examples in a batch. PATCH. And the second dimension is time step. And the third dimension is actually the number of features. So since we are talking about the music, I can explain this one with the score. So we have 5 lines, and there are some notes. Now maybe this is the first note, and I have another note. Then in this way, I can write the number of examples in a batch is 2. But what about the time step? Here is 1, 2, 3. Okay, I want to make it as the same all over there, has the same duration. But for the RNN, it's really special that even if this one is 3 and this one is 4, you can have it. But for now, I'm just make it the same as 4. So it's 4. And the number of features. And in this case, at every time step, we have just 1 numbers. But for example, we have a chord. So there's another notes here. And it could have another notes here at the same time. Then it should be 2. And even if there is no notes, we assume that there is a note. So it's very important to see it always need 3-dimensional data. And first one is the number of samples in the example. And then the second one is the time step. And the third one is the number of features. And in our case, we have only 1 number of features. And then time step, it's probably the sequence length. So now I'm going to back to the top first. So that's why I need the bracket here. So before we add the bracket, this is just a 20 numbers. But since I add the bracket here, the shape of this one is 2-dimensional. Okay, now I'm going to make a batch of 2. And then see what's inside. Now you can see the dimension is 3-dimensional. So that means we have 2 examples, and the time period is 5, time step is 5, and there is only 1 feature. Then okay, then this one is the X, and the 4 is the Y, and this 1 to 4 is the another X, and 5 is the Y. So I'm going to take the first one and then see what's inside. So it's 2, 4, 1. So 2 examples, and then 4 time step and 1 number of features. So this is my model, and I'm going to put the first one, and it gives me 2 numbers. So recurrent neural network at first it's really confusing because the number 4, the time step element is going to be gone, because what it does is, let's say we have 0, 1, 2, 3, Then first it takes 0 and then produce some outputs. But some output will goes in this way also. And then the number 1 goes here and do something and produce output to the bottom and also to the left. And here the same thing to the bottom and to the left, and input and do something and produce output here and here. And what we see is actually this one. So we cannot see these guys. So that's why the time step is gone, because even if we have 10 time steps or 100 time steps, it goes all the way through the time step, and the final thing we will see is just the final output. So in that sense, the number 1 is not really related to the time step. It is actually the final output, size of the final output. So for example, if I change it to 10, then at first, if you think about the dense layer, you may think that yeah, there is a 10 node, but actually it is not. So make a model and then put in the same data set, and you will have 10 numbers for the first example, and you will have another 10 numbers for the second example, because what you see is this number. Okay, there is a question. Google it. Yeah. So that is the first obstacle. And I drew a picture of this. So actually the picture that I draw on the whiteboard is this one. So we are going to put into the X1. That is going to be our first feature. And we assume that there is some hidden initial force. And usually at the start, this initial force, so I'm going to say it is a hidden force, and it is usually set to 0. And then inside this rectangle square, what is going to happen is this equation. So 10H is, just forget about the 10H. What you need to see inside is just a linear relationship between X1 and H0 and plus the bias. So do some linear regression and then take the activation layer as the 10H. And we don't care about whether it is a 10H or the sigmoid right now. We just focus on there is some linear equation. And then it will produce H1, which will be passed to the next number. And then X2 is going in, and with X2 and H1, this cell makes the another hidden state, H2, and go all the way to the final one. So that's the number we see at the end. Okay. For this week's assignment, so we are not going to use this one. But for the next and the next one, and I'm thinking that your final project is going to be the RNN, because this is not simple enough to just yet put the image data and then classify it. And this is not so simple as the CNN. So I'm thinking that I'm gonna put the Kaggle, not Kaggle, the final competition, the final project will be recurrent neural network. And that's it. So this is just the first touch of our introduction to the RNN. And you have to think about it again and again, because as I said, it's once you understand this is not so complicated as you might worried, but at first it is really confusing. And the many of your the most of your work will be on the data step, not the actual the RNN networks. But to achieve that level, yeah, you have to understand the basic structure of the network. I'm not sure. It can be, I know that, yeah, it can last for 2 weeks. But yeah, just to learn in 2 weeks. And there are another video. So for example, the RNN basic, this is on the YouTube. And I explained it, actually in this video, I did made an error. So, but that error was intentional. But today's error was not intentional error, but I just did it wrong. So I can make it here for 2 weeks. Yeah, today's lecture. Yeah, because of this MIT video, she explains everything about the RNN. But in order to understand what she is trying to explain, you need to take the class. So this one looks very, at first it looks very easy, but you will get some different versions of the RNN. So for example, I did not do the simple RNN collab here. I did not do it yet. I'm gonna move it to the next week. And there are 4 different versions of the simple RNN. So I said, yeah, the simple RNN and then put just one number, but actually you can control the return sequence and return state. There are 2 more parameters, and you can set it to true or false. And depending on your choice of your parameters, your output shape will be totally different. And this is just the beginning, because when we go to the another RNN network, which we'll call the LSTM, there is 1 more parameter. So the total number of different models is 8. So don't worry too much. Just focus on the simple RNN first. And we don't care about the parameters, the optional arguments at this time. We just look at just one number. And important thing is that what is the shape of the simple RNN? The second dimension is always time dimension, and that time step, the time step will be exhausted when we go through the RNN. And then final output is the dimension of this, the final output of the RNN network is have the size of this number. So that is the 2 things you remember for the first simple RNN network. Okay, I think that's enough. Yeah, okay. I can upload this Zoom lecture on the YouTube, and I wanted to be listed here so that the other people can see what I was wrong. Yes, we will have 2 more assignments and the final projects. But or just 1 more assignment and final project, because uh, as we move to the final, you will have lots of burdens. So I may give some one assignments to be skipped, so that but this is not decided yet. So basically we have 2 more assignments and final project. No, I don't take. I don't care about whether your recording is absent or not. I don't care about that. Okay, so for today's this week's assignment, just use the random feature and use the different choose the different music and use the random feature, and then make a MIDI file at least 1 minute length and upload it to the Learn Us. And then try to think about the simple RNN that I talked today. Okay, thank you for listening, and do your homework first and then submit it, and have a nice weekend.